This episode is brought to you by Datadog, a full-stack monitoring platform that integrates with over 400 technologies like Gremlin, PagerDuty, AWS Lambda, Spinnaker, and more. With rich visualizations and algorithmic alerts, Datadog can help you monitor the effects of chaos experiments, identify weaknesses, and improve the reliability of your systems. Visit datadoghq.com/Hanselminutes to get a free 14-day trial and receive one of Datadog's famously cozy t-shirts. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Simon Ferquel. He's a senior software engineer at Docker. How are you, sir?
I'm really fine, and you?
I'm very happy to be talking to you. I'm a big fan. I like to follow you on Twitter and see all of you're so helpful. You're very kind because everyone's always asking you Docker questions and you're always there to help. But I know it's not your job to be helpful on Twitter, but you just love the product, right?
Yeah, actually, it's really interesting for me to stay in touch with our users, and actually, it's really easy for me to be empathetic with our users because our target is actually developers, and when some developer has a problem with Docker Desktop, I really feel the pain. It's nice to be able to talk to them on Twitter or GitHub, etc.
I think that's really cool. Sometimes, companies like Microsoft, I think, does this a lot. They separate the developer and the program manager. Like the PM is supposed to talk to the customers and they hide the developer in the closet somewhere. But at Docker, it seems like the developers like to be visible.
Yeah, it might be because of our open source background and the fact that we always have had a culture of developing things in the open. Even if Docker Desktop itself is not open source, we are still in this kind of mindset where we do open source projects and we share a lot with the community. We leverage our community to build stuff.
That's really cool. And that actually brings up a good point. So you say that Docker Desktop, I'm on a Windows machine, Docker Desktop is not open source. Maybe you could explain the stack, because people use the word Docker kind of like in America the way we use the word Kleenex, right? Like Kleenex is a tissue, right? But if you say, hand me a Kleenex, it could be any brand,
Yeah,
or
sure.
in America, you can say, give me a Coke. And then they say, what kind of Coke? Well, Sprite or Pepsi. Like, it's becoming a word that means containers. But when I install Docker Desktop, what am I getting and what is the stack and what does each component do?
Yeah, so Docker Desktop, basically it's a distribution of all our tools. The first thing that ships is a Docker daemon, and on Windows we ship actually two daemons. We ship the Windows containers daemons that runs natively on Windows, and we also ship the Linux daemon, so Docker D, that runs either inside an Hyper-V VM, or if you are running WSL2, it can also run within WSL2 itself. Aside this, those daemons, we also ship all necessary client-side toolings like the Docker CLI and also Docker Compose. We ship also Notary. We ship kubectl, the Kubernetes CLI, and something that we also ship and that is not necessarily well known is that we distribute Kubernetes as well. So with Docker Desktop, you can just enable the Kubernetes API just by clicking a button in the UI.
So it's a toolkit. It's a complete toolkit for all those things. And I remember just a few years ago, we would have to install each of these things kind of separately. I remember installing Docker and then setting that up and then getting Docker Compose, and then Kubernetes was a whole other thing after that.
Yeah, so the idea behind Docker Desktop is to get a seamless Docker development experience on Mac and Windows. So what we do is we try to seamlessly blend those things together and make them feel like you are running on your production server. So something that, for example, that we handle for you is bind mounting files from the Windows environment into your Linux container environment. And this particular example is very tricky, and this is part of the shine that the polish that we make with Docker Desktop. It's not something that you could do yourself, and that we are really happy to bring.
Some people who have used Windows before, who are not Windows people, complain because they say that installing Docker on Windows is too hard or it's a hack, and they say, "Oh, on Linux it's super easy," because Docker and the idea of containers is kind of baked into Linux, but it's not exactly baked into Windows. Is that right?
Yes, that's right. And actually, it has changed a little bit with since Windows 8, I think, where there is this notion of app containers on Windows. It's a different kind of container than what we do with Docker, but it shares some similar aspects. Like on Windows, sandboxed apps don't share the same registry, don't have access to the real file system, but they go through a broker, something like that. So there are some common things between Windows sandboxed apps and Docker containers. But to come back to the question and why it's hard to install Docker on Windows, I think it's mostly because what we do for making the experience seamless is actually quite complicated. We have to deal with virtualization. We have to deal with bringing virtual network interfaces. We have to deal with so many different kind of Windows configuration and conflicting software. Like if you run VMware, for example, and as Docker Desktop depends on Hyper-V on Windows, there are basically nothing that we can do. So yeah, there are a kind of a long list of prerequisites, and we try to make this list a lot shorter by leveraging on things like WSL2. But it will always be something complicated because at the end of the day, we need to run Linux, and we need to run Linux executables on your Windows machine.
Mm-hmm. And early versions of Docker Desktop, I'm thinking maybe a year or two ago, I remember installing it and I knew that it would use Hyper-V and it would fire up a virtual machine. And I would go into the Hyper-V manager and I would see a virtual machine and its name was Moby. What is Moby?
Yeah, Moby. That's kind of fun because it's the name of this VM predates the launch of the Moby project that we did a few years ago, and it was just kind of a very cool name to use aside Docker, like Moby. It's the name of the whale, by the way. So this Moby VM was actually the whale that hosts your containers, and yeah, it was kind of fun to use that name there.
So Moby Dick is the whale in the book of the same name, and the Docker logo is a whale with containers, like a container ship on
Yes.
top. And this is because everything's nautical, right? Kubernetes uses nautical names. Everything's about the ocean.
Yes, exactly. We always have used this analogy with shipping containers and with how to say the big boats that
container ships.
Yes, container ships actually, and Kubernetes has taken this analogy a bit further than that.
Mm-hmm.
But if we come back a few years ago, we launched this Moby project that you might be aware of. And actually, it was a way for us to separate Docker as a product to our open source project, which we rely on for building this Docker daemon.
Okay. So when I would install this, I would, and this is a couple of years ago, I would see this little virtual machine kind of get created. So you were basically automating Hyper-V, making a virtual machine in the background. And I had other virtual machines, like I had an Ubuntu virtual machine that I would run in Hyper-V. It seemed to work pretty well, but I felt that the startup time was really long. Like I would wait for quite a while. And it was pretty clear that there was Windows, and then there was Docker talking to Hyper-V with this, couple of megs of memory, couple of gigs of memory rather, and you were basically sitting on top of Hyper-V. But then most recently, that went away and things just got faster and better and more integrated. And now I don't feel like Docker is sitting on top of a hack. I feel like it's very native and very fast inside of Windows. Can you help me understand what changed and what the architecture difference is?
Yeah, so originally we created our own VM, and as you said, we actually automated Hyper-V in a way to run our VM, wait for services to start up there, and set up interconnection with the desktop front end, etc. And yeah, and starting a VM, it takes some time. It takes some time, except if you are actually Microsoft and you have total control on both the hypervisor, the host OS, and the Linux environment itself. So, and that's what Microsoft did with WSL2. So what we rely on now, now that WSL2 is shipping, is the fact that Microsoft provides a real Linux kernel running in a utility VM that boots under 2 seconds, I think. And so we leverage this on Linux environment to run our services. And the funny fact is that we run exactly the same payload as what we run in our own utility VM with Hyper-V. But it's just that instead of booting a full-fledged VM, we actually run the Docker desktop backend in a container within WSL2. The tricky part is to create this container without having Docker in the first place. So we talk directly with Linux kernel APIs to set up our isolated environment within the utility VM and spin up things from there.
So it was announced this week at Build that the version of Windows, I think it's 2004 or 2004, which means 2020 April or spring, is the one that has WSL 2, which is our favorite version of the Windows subsystem for Linux. This is the one that is the best choice. So if you're doing Docker on Windows, you really are going to have a great experience if you stay on WSL 2. You would not recommend doing it any other way?
Yes, really. It's much better with WSL2 in terms of performance. In terms of startup, we start in under 10 seconds on a modern machine, which is really awesome compared to what we had with Hyper-V before. And after that, it also integrates really well with your own WSL2 distros, so that you can have native I/O performance when you bind mount things from your distro to a Docker container, and things like the WSL2 VM runs with dynamic resource allocation, so we can consume as little resources as we need and scale to as much as we need in terms of CPU and memory to run your payloads. So yeah, overall the performance are much better with Hyper-V than with WSL2 than on Hyper-V. And so yeah, I would really recommend to upgrade to 2004. And although there is an interesting fact is that WSL2 is also running on Windows Home. And previously, as we leveraged Hyper-V, we could only run on Windows 10 Pro. And with WSL2 now, you can install Docker Desktop on Windows Home and develop Linux containers from your Windows environment.
That's really huge. I know it's a little confusing because if you go to Windows features, there's Hyper-V and then there's virtual something platform?
Yes, Windows Virtualization Platform, I think. Yeah, that's quite funny because it's actually just two ways to install the same hypervisor. So when you install the fully fledged Hyper-V, you don't really need this new feature, Windows Virtualization Platform, for WSL2 to work. It just needed if you are running on Home or if you don't want to install Hyper-V or the whole set of Hyper-V services on your machine.
So this unlocks the ability to use Docker on anyone out there who has home. So that means students, anyone who doesn't want to pay the extra money for Pro, because Pro includes a whole bunch of other stuff. And that's a huge thing to make that available. So you can't, if you have home, you turn on the virtualization platform, you can use Docker, Docker Desktop, Kubernetes, all this stuff. You just can't use the Hyper-V virtual machine stuff where you're actually opening up like an Ubuntu full square, like a full virtual machine on Linux, right?
Yes, and there is a fun fact. It's that you can't use a Hyper-V backend, but you can't use Windows containers backend either, because Windows containers is a Windows 10 Pro feature. So that's really funny because you can develop Linux containers, run Kubernetes, etc. But the Windows container support is not there on home.
Well, what's really nice, though, is that you can use WSL, you can use Visual Studio Code, and you can get a really lovely experience for developing.
Yeah, no, I really like to highlight the experience with VS Code remote to the WSL feature, which allows you to run VS Code backend within WSL itself, within your distro, and so that fits really well with Docker Desktop and the WSL backend. So this way you can actually target a Linux production environment using Linux build scripts and things like that, and get your nice IDE experience on Windows. And yeah, that's really awesome. And that's actually the way I develop day to day on Docker Desktop when I have to deal with the WSL backend. I use WSL to develop the WSL backend. That's really cool.
No one wants to manage databases if they can avoid it. That's why MongoDB made MongoDB Atlas, a global cloud database service that runs on AWS, GCP, and Azure. You can deploy a fully managed MongoDB database in minutes with just a few clicks or a few API calls. MongoDB Atlas automates deployment, automates updates, handles scaling, and more so that you can focus on your application instead of taking care of your database. You can get started free at mongodb.com/atlas. Now, if you're already managing a MongoDB deployment, Atlas has a live migration service, so you can migrate it easily with minimal downtime and then get back to what matters. Stop managing your database and start using MongoDB Atlas. Now, there's being able to go into WSL, type code, and then you're in Windows using VS Code and you're doing your compilations in Linux. But then there's what are called dev containers, where you have a .dev container file, and that works amazingly with Docker Desktop. So you can go and have a folder, put some stuff in it that is some source code, but you don't have, for example, Go or Rust or Python. And then Visual Studio Code fires up and says, oh, this is a development container, because it sees a little text file that says .container, .dev container. Then it opens again and does all the Docker work. It installs everything you need so that your entire stack of development exists only in Docker. And with Docker Desktop on Windows, it just works. It's like impossible.
Yes, I really like this approach of working. And to go a little further than that, it also allows to work on long-term supported software, and don't have to deal with issues whenever you need to upgrade an SDK or something like that for building your software over time. You don't have to think about, oh, by the way, I have a version that dates from 1 year ago that I still need to support for 3 years. Will it work with the new version of the tools, etc.? One thing that the development containers feature allows you to do is to actually version your toolset alongside your source code. And that's really cool. So that at any given point of time, I can go back the version of the tooling that I used to build my product at that time. That's really cool. And I wish we could use that with Docker Desktop, by the way.
Oh, yeah, that would be amazing. I'm looking at my WSL. So I type WSL -- list, and it lists out like I have Ubuntu and I have WLinux and I have the different, and then I have one that's called Docker Desktop. That's your WSL distribution. You're effectively, rather than making a big heavy VM in Hyper-V, you're making a tiny lightweight WSL distribution. And when I run a container, it runs inside of that distribution. Is that correct?
Yeah, so we actually run two distributions. One that has absolutely no executable, which is just there for backing your container configuration, volumes, and things like that.
Mm-hmm.
We use it basically as an additional VHD that we attach to our main distro. And there is this Docker desktop distro, and what it does is it's a very small distro which contains a code that creates the actual container that runs our backend, our set of backend services. So it contains a single WSL bootstrap executable. If you enter it using WSL-D, and while Docker Desktop is running, and you run PS, you'll see, or PS3, you'll see that there is this WSL bootstrap that creates a new container, and you can see the init process within this
I
container.
see it right here. I actually just did that. I said WSL-D, Docker Desktop, WSL Bootstrap, and it says program files Docker for WSO.ISO. You mounted an ISO.
Yeah. That's actually we use the same tooling that what we use for building the Hyper-V VM. So the Hyper-V VM is actually based on two ISO that we kind of merged together. One that contains the base of the Linux distro, and one that contains the Docker-D version and things like that. That allows us to easily swap the Docker daemon version from one version to the other, and the same for Kubernetes and things like that. So we stitched these two ISOs together, and we attach a VHD. And what we do with WSL2 is that we basically do the same thing. We have the same those same two ISO files. There is one that is a little bit different than the Hyper-V side, but it's mostly the same code, but packaged in a slightly different way. And we bind mount a directory that lives in the Docker desktop data distro inside what we call our Linux Git environment, so that we have the same feature as a VHD, but implemented as a bind mount from Docker desktop data to Docker desktop distro.
One of the things that's most amazing, as I have kind of now I'm in the WSL2 environment compared to when it used to work, was I always felt like Docker was kind of layered on top of Windows. But now when I say Docker images, right now I'm looking in my PowerShell, I see Docker images and I see my images. I go over to my Ubuntu on the same machine and I say Docker images. I see the exact same images. Like it is one Docker on the machine rather than what I used to see, which was different context. But when I go and say Docker context ls, inside of Ubuntu, it says Docker endpoint var run, and I go over into the Windows world and I see a different thing. Which one is real? We're piping somehow. I don't understand this idea of context. Can you explain that?
This idea of context, it's nothing really to do with Docker Desktop. It's something that we added to the CLI that allows you to store the credentials and configuration to talk to various Docker endpoints with the same CLI, and switch from one to the other just by using Docker context use command. And that's pretty cool for ops people, mostly that have to deal with many different production and staging environments and deploy things on those endpoints. Actually, if you look at those different server address on Ubuntu and on the Windows side, actually they are both right. And that's because they don't talk directly to the daemon. we actually run a little proxy on the Windows side and on each distro where you have activated the Docker Desktop integration.
Mm-hmm.
And this little proxy allows us to do a couple of things. And the most important thing is to actually rewrite all the bindments that you do. Like if I'm on Windows and I want to share my C drive inside a container, we need actually to instruct to change the path that you say on at your input. So in your command line, you'll say, I want to mount C colon something into /var data, for example.
Mm-hmm.
And to do that, we actually need to map this C colon thing into a path that corresponds to the C drive moon point within our Linux environment. And actually, that's the same thing when you are on Ubuntu and you want to bind mount your home drive inside a container. As we are running Docker in a different mount namespace, we need to actually convert the path that you give us on input into something that Docker Desktop can actually see. And there is a tricky part, and the biggest complexity in the WSL integration is actually there. It's making sure that we get very, very good I/O performance, really near native I/O performance when you bind mount string, and at the same time we need to translate paths correctly and share data between one distro and our own Docker Desktop distro.
For the most part, everything just works. Like you're saying, well, this is a little tricky and this is a little tricky, but you're doing the work. So the result is I'm able to go and do my development very, very naturally without having to worry about anything. Like it feels native and it is incredibly fast. In fact, I'm doing all my .NET Core builds using Docker on a local machine now. And because I'm using WSL2, it feels like I'm on the metal.
Yeah, and we are really, really happy with that. Actually, and sometimes we have some bugs with this kind of system, and as it feels so easy to use, most of our users think it's really simple under the hood, and actually it's not. And and sometimes our users complain about bindments don't work correctly on the Windows side. Performance is not as good as if I bindmount from WSL itself or something like that. And actually, yes, it's true. It's tricky, and there is a lot of work behind those kind of features. And for a long time, we had problems with bindmounts with Hyper-V, and there are a whole category of issues that we had to work around with sharing your C drive into a container that runs in an Hyper-V VM. Things like the Samba server on the Windows side can be disabled by a GPO, or it's not reachable from a foreign computer if you are enrolled in a Azure Active Directory or things like that. There are so many cases where we just can't do anything, and it's not really reliable, and we are not happy with that. But yeah, and this tension between user feedback saying this doesn't work and us saying yes, we know, and it's already so difficult to make it work the way it works today. And yeah.
Mm-hmm. So, but if people have Windows 2000 or 2004, so Windows 10, the version that is in the first quarter of 2020, and they get the Docker desktop latest stuff, they go into resources, WSL integration. They just have to click enable integration with my default distro. You handle everything. They don't install Docker in WSL to get started?
Yeah, no, they don't need to. We actually ship the Linux CLI with Docker Desktop, and we actually create symlinks to the binaries that live within the Docker Desktop distro from your environment. So everything is in your path. When you enable the integration, you can type Docker or kubectl, and it just gets resolved. There is only one case where it's a little bit trickier, is for distros that doesn't come with a glibc. Distros like Alpine or things like that, where you need to install a glibc compat layer so that our executables can run on your environment.
So the easiest way to get started is to make sure you've got the latest Windows, you've enabled WSL, and now at build they announced they're going to make it even easier to just say WSL install Docker Desktop, and then you're ready to go. And you can just, even like you said, check a box and get Kubernetes, and and it all gets better with Visual Studio Code, of course.
Yeah, sure. Yeah, that's exactly that. And yeah, I really wish that we could brought this level of experience and performance to more users, like people running with current version of Windows 10 or 1909 or something like that. I really hope that we can at some point reach them with this WSL2 backend as well. But that doesn't depend on us, and yeah, maybe Microsoft will want to backport WSL2 or something like that.
It would be really cool that people could do this kind of good stuff, and because not everyone can upgrade to the absolute latest Windows.
Yes, and yeah, that's always a problem with new APIs. And in the past, we have struggled with doing the choice of leveraging a very recent API, and it's mostly because on our side at Docker we need to support people with a very broad range of versions. And yeah, and for WSL2, it was obvious that it was a very good fit, and we wanted to leverage that. But for many cases before, we just went back and said, "Oh, it actually adds so much complexity to detect Windows versions, detect if the API is there, have fallback solutions and things like that." So for now, we consider, for example, that the whole Hyper-V backend is our fallback mechanism for when WSL2 is not available. Yeah, and it gives you some kind of view about the choice that we have to do between leveraging a new API and having to maintain multiple code paths for doing the same thing. And I think WSL2 is just a very bright example for that. Like, if you don't have WSL2, we need to do something and make it work anyway. And yeah, and that's Hyper-V, the previous Hyper-V backend.
Yeah, I think that WSL2 is definitely the future, and it's just going to get better. And the stuff that we learned at Build this week, I'll make sure I put links in the show notes. I'll also put links to both you on Twitter as well as to go and download Docker Desktop that folks can do right now. Thank you so much for chatting with me today. This has been another episode of Hansel Minutes, and we'll see you again next week.